Hello, welcome to this fourth part of the video on the scientific writing course about figures and tables also in this part. So I'm again Inge Grünberg, Julia's postdoc, and this is the last video of this figures session. So what we covered before is some general design principles and the content that how you decide what to put in a figure, and also the different figure types. So we talked about pictures, which is the main part of data reproduction, about schematics, maps, and about plotting numerical data. Today I will explain a bit more about some general design elements that you will have in all your figures, talk about convention, and then mention some tools that are good to produce high quality figures. And in the end I have a wrap up on figures, so recommendations of what to do and what not to do. And I have a very short part about tables. So the first design element that you will have in most figures is color. Color is very important because of course it attracts attention. If you have a lot of text and then a colorful figure, everybody will first look at this figure. Attracting attention of course is always a good thing because people will want to look at your figure, wonder what it is about, and then even read up more details in your paper, even maybe if they didn't intend to spend much time on it. But on the other hand, color can also be distracting. So if a figure is very colorful, it might be more difficult to find the major point of this figure. And that is an example that I had in the last video, where a very colorful figure was a bit misleading in terms of about its actual content. So that's always where you're in between, if you use color, between it's distracting or it attracts attention. When you use color, of course, you have to be aware of the fact that not everybody sees color in the same way as you do. Almost 10% of the male population, I think, are color blind, much less for females. But definitely that's a big group of people that you need to consider when you use color in your figures. So here I have an example of what kind of normal color vision would show, these pens. But this is a very frequent type of color blindness where red and green, like this pen and this pen, look almost identical. And then there are also some few people who have a different type of color blindness, not being able to tell apart red and blue, I thought. Maybe it's also green and blue. So different types of color blindness definitely imply that you need a different color palette. And also it's always good to consider people who still print your article in black and white. I know printing got much less popular and also it's not so environmentally friendly, but still it's always good if a figure or the major part of a figure is also visible in black and white. And of course nowadays the internet offers a lot of tools to decide on a figure palette. For example, this color brewer, but also there is special palettes designed to be good also for colorblind people. These three examples are very nice, I think, so it can also be appealing for other people. Just pay attention, make sure that if you use a red and a green, for example, the red is light and the green is dark, or the other way around, so that there are still differences even for colorblind people. So the next part is about fonts. You don't necessarily notice right away, but the different fonts make quite a difference in a figure. For example, this is a standard sans serif font. This is Helvetica, but it looks very similar to Arial, for example. This is Times New Roman. This is a serif font, as you see here at all these little marks at the letters. And then there are special fonts, like this is a mono font, where every letter has exactly the same space. This kind of font is most often used if you display code. For example, some Python code. This would usually be in a mono font. And if you have the same figure with these different types of fonts, it looks very different. Of course, it's a matter of taste. You can choose any of them, but I would advise you to always choose the same throughout all your figures of the manuscript. And definitely never ever mix them within one figure, have like the axis labels in one font and then the legend in another. That's not very advisable. And of course, font size, I mentioned a lot of times. Please make the fonts big enough, especially because your figure is usually scaled. The journal will scale it maybe to 1 column, and then some people even print 2 pages on one. So make the fonts big enough so they are actually readable without glasses even. The next thing I want to talk about is conventions. And that's something very implicit. Nobody usually tells you this. And this is just some examples that I could think of, but I'm sure there are many more that I also wasn't aware of. But actually, when something doesn't follow a convention, you notice, and it's strange, and it might be harder to understand. So let me just introduce you to some very basic ones. For example, the x-axis usually shows the independent variable, the cause, the driver, however you call it. While the y-axis shows the dependent variable, or the effect, the response. So usually that would be the way you plot it, cause and effect on x and y, and then everybody would understand what it means. And also, for example, if you include a linear regression, that would also be a useful regression, because the x is the cause and the y is the response. Then also usually with x-axis you have it that like on the left side it's earlier or smaller, while it gets bigger or later in time towards the right. And it's very important that x's, if it's a numerical value, they are equally spaced. So please, if you have 1, 2, 3, here it needs to be 4 and not 10. Everybody will assume that implicitly, and this is a very important thing. Otherwise, it's super confusing. If you really need to show 1, 2, and 3, and then 100, 110, and 120, you need to like cross out the axis here, make 2 dashes, and really show it, emphasize that this is a break in this axis. Box plots, for example, usually show the median, then the 25th and 75th percentile, and the whiskers are either minimum and maximum of your data, or the 5th and 95th percentile. Of course, you can do it differently. That's the case with all of these. But if you do it differently, you definitely need to highlight it so people directly see that it's different, and you need to mention in the caption. Also, maps follow a lot of conventions. For example, usually if you have a digital elevation model, green would be low elevation, red, or even then violet and white would be high elevations. On the other hand, if it shows land cover, this map, it would usually be red, more for urban types of land cover, while green would be used for natural land cover, forest, for example. And it would be really confusing if you would have like a red forest. Of course, that's something you can do if you really highlight specific types of forest or so, but you have to be aware that will make people confused at the first sight. So it's always good to first at least think about these conventions, these implicit things that everybody does, and then you can still make up your own way, but you need to make sure that it's easily understandable. Also, please always make north up. Also, if you have like a weird sketch of the landscape, and it would be so much easier to just turn it around. It's really nicer if north is up for most people to orient themselves in space. For example, if you plot the whole world with south up, that is a very unusual thing, so people will look at it and find it interesting. You could state it as political opinion, for example, that it's unfair that it's always north up while this global south is not regarded so important. So it's okay, of course, to do that, but you have to think about the impression that it makes, and if you want the reader to concentrate on this fact, or what is your major point in general to show this map. Then a short word on captions. I mentioned before that the figure, including the caption, needs to be self-explanatory. So all the information needed to understand the figure has to be stated in the caption. And this includes, for example, the major method or the major parameter used in a model. Can include sample size, depending whatever is most important to understand your graphic. And also please avoid abbreviations. So if in the axis label, for example, you have an abbreviation because it just doesn't fit otherwise, you explain it in the caption. Even if you explain the same abbreviation also in the text. But you can't really assume that the reader will read the whole text from the beginning to the end before looking at the graph, so would already know the abbreviation. Most people, including me, read a paper very differently, and I think Julia has a video on that. For example, I usually, of course, look at the title to figure out if it's interesting at all. Then I read the abstract, maybe the conclusions, but definitely I go through the paper very quickly and look at the figures. Because usually it's much easier to get like what they did and the figures. Often you find a map of the study site, so I directly know, oh, it's northeastern Canada or another study site. And I don't need to go to the text to figure out where their study site is. Or I find a picture of the landscape or the study object. And the major result, everything will be shown in figures. So it's really, for me, easiest to go through the paper while just looking at the figures. And then, of course, if it's very interesting and I'm interested in the single methods or more details on the result, I will also read the text, but the figures I will definitely look at. So that's why the captions need to include all details to understand the figure. And I have again here the example from my friend Irena. This caption is quite long, although it doesn't even contain all the abbreviations. You see that you'll often have a caption that almost takes as much space as the figure. That's unfortunate. Nobody really likes it, but it's just this way. It needs to contain so much information. So a short word on tools. One thing I'd really like to encourage you is to use a tool that allows you to reproduce the graphic very easily. This is for two things. First of all, as everything in science, reproducibility is a very important point. So if you do your graphic with a lot of manual steps like copy, pasting and clicking and then using some kind of menu to change something, it's not reproducible because usually you wouldn't write down a list of all these steps. And that's something that's generally should be avoided in science. But also, it's super annoying if you did a figure, you spend a lot of time doing all these manual steps, and then your supervisor comes and says, well, but by the way, now we got some new data. Please include this extra month of data. And then it would be so unfortunate if you decided not to include this new data just because it was such a pain to create the figure. So it's much better if you can come and say, yeah, of course I include the new data. I will just have to run the script once again, and then I see if it changes something and I have the most accurate or the newest data included. So this is something that will often happen, that you first do figures, but then your supervisor or co-authors suggest to include also something else. And then if you have it in a reproducible way, it's much, much easier. You can also produce more different versions of the figure to decide what is the best version. So what I do for my figures, also the ones that I presented in the last video, is I use LaTeX. They're really great packages called PGF plots and ticks for more the schematics. Actually, of course, I use LaTeX for all my writing. So that's why it makes sense to also use it for the figures, because then I have everything in one document and it's very clean. It also can export the single figures as separate PDFs, so I can just upload them in the submission process. So I think it's very convenient, and you have many great options for different types of figures, and it's very easy to customize them. But of course, I completely understand that if you don't plan on using LaTeX it's probably difficult to just learn LaTeX just for making figures. Another tool I used before is GNU-plot. That's a very nice one, you can check it out. But most people will anyway at one point learn like a scientific programming language. And of course, with all these languages such as Python, R or MATLAB, you can actually also produce publication-ready figures. I find it's a bit of a pain sometimes, but definitely if you learn it and you spend some time on figuring out how to customize your figures, this is definitely a good option. Also, maps can be done with Python, for example, or R, but here I would advise you to use QGIS or ArcGIS because it's much easier for maps. Then for schematics, there are a lot of different tools. I just mentioned Inkscape here because it's free and I use it. I find it very convenient. But of course, you can use different ones for schematics. Also, sometimes I use LaTeX for schematics. One thing I want to mention here also is that it's a very good idea to have interactive figures if they are published on a website, for example. And this is where you really need Python or R, probably MATLAB. I don't know, I'm not working with that at the moment. But there are great packages like Plotly or Shiny, where you can do complete dashboards with several figures, including the legends, where people can zoom in and look at specific values and really interact with the figure. And that's always very nice if you have it on your website or your project's website, your university website. And then there are packages like Bouquet, where you can really just have a single figure and include it naturally in the text of the website, but with all the interactive possibilities. But that's a bit more tricky than using Plotly or Shiny. So please, please, please use a tool that allows you to do everything that you want. So don't let the tool you use define what kind of plot you can make. But first think about the content you want to show, how you want to show it, and then decide on a tool that allows you to plot it exactly in the way that you've imagined it in your head. And that probably excludes Excel and PowerPoint. Let's start with the summary of all the recommendations of what to do and what not to do. So here, first things to avoid. Everything that distracts from your main message should be avoided. I have this example here again that I showed in the video before, so avoid extensive decoration, for example. Then please avoid pixel graphics for everything else but sheer pictures. And these pictures also should be in a high enough resolution. But as soon as you combine a picture with text, you can have the picture in a JPEG, but then include the text as an additional layer and save everything as a PDF. Please, 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 because then it will have a very high resolution. The text will never get blurry or distorted. And also you can, in terms of reproducibility, you can probably also increase the font size in this one step and you don't need to reproduce everything. Then font size, please use a big enough font, so avoid barely readable font sizes. Avoid different fonts, different colors and everything in different figures of your manuscript, so stick to one sort of design. Please don't ignore conventions. Of course you can break them, but only for a good reason. And please avoid bar charts and pie diagrams. So why that? I know they are very popular, but I don't quite like them because with a bar chart or a pie diagram, you have no opportunity to show the uncertainty you have, the scatter you have. You really can't show variability. So please make up your mind, think of a different way to plot your data. Already a box plot, it's kind of like a bar chart, but you can show your variability, so it's already better. But there might be even more creative ways to show your data. So please avoid these very simplified types of graphs because it's always good to show a bit more information. One thing that you definitely need to avoid is that people who look at your figure get a wrong impression of what you want to show. For example, here, This is a very simplified figure. I don't like it at all, but what I want to show you is that it allows a false interpretation, because actually it's the same data, but with this 3D version, it looks as if, for example, this would be below 8 and this would be below 12, while it's actually above. So while doing this 3D effect, we lose information and it's harder to understand, and people will probably misunderstand it. So just avoid it. Don't use 3D unless it's something that you really need to show in 3D. And then I have this figure. I show here also the data that I used to produce it in Excel. And I'm very unhappy with the figure. I did it just to show you what can go wrong. And one thing that definitely went wrong is that I have missing data here, and it just doesn't show that it's missing. So here's no 6, we have 10, 11, and 12 is missing, and it just seems to be naturally following. So this is not equally spaced, and there's no indication of a data gap. So this is definitely something to avoid. And also I show here the original values, more or less. And you see that with this kind of smooth line, we also get a wrong impression of the data. Please don't use this additional artificial smoothing. For example, the maximum value we have here is 12. While here we have the maximum, which is above 12. I don't know, not too much, maybe 12.2, but still it's misleading. Or same here, these two values are actually the same, but this indicates that between the two values it got lower. Maybe that's not the case. Maybe it doesn't even make any sense if this is not a continuous axis, but if only single values are possible. For example, this is day 1 and day 2. There's no day 1.5. So why should be day 13.5 have a lower value than 13 and 14? So this is very misleading, so please avoid it. So let's come to the positive side, so the recommendations of what to do. So first, define your message and content. That's always the first part of plotting, not looking at data and plotting it, but first, if you want to have the figure for your paper, define your method. Then make your figure as simple as possible and readable. You can use additional text to point the readers to important patterns. Like here, this example shows some specific values. And then please be honest, show all your scatter, your uncertainty, your data gaps, and maintain a consistent design. Use the same colors or symbols for the same thing, use the same fonts, the same font sizes, same grids. And what's always good for a scientific paper is to arrange multiple figures in a single display, because then it's just one way to show more figures, even though usually you have much less in a scientific paper than, for example, in a master's thesis. And if possible, you can make your graphics interactive. That's what I mentioned before with the new tools that really appeared in the last couple of years. It's a great opportunity to have an interactive graphic using Python or R as a background. So that was everything I wanted to tell you about figures. I know it's a lot of content, but as we do these videos, maybe you can look at some parts again if something's unclear. And this is what I want to tell you about tables. First of all, tables are really the best way to hide data. So if there's something you don't really want to show, put it in a table. That is why most papers really don't have many tables. You find them much less often than figures. Tables are only good if, for example, the exact value is very important. If you have a model parameterization and you want other people to use exactly the same parameter values as you did, it's a good idea to make a table with all these parameter values so people can just read them and include them in their model. If you really want to have this precision, it's a good idea. Or if you have really a lot of data that doesn't fit into a figure. For example, here, this study had not only these 15 study sites, but like 200. And of course, you can also include them in a map, and I'm sure they did. But they want to have additional information. For example, the citation, where they found the data, the environment, and the forest type. some kind of name and code. So this really doesn't fit all to a map if you have 200 sites. So that's where a table is a really good idea. But probably most often these kind of really big tables would go to the appendix. Usually you find the bigger tables in the appendix, and the main part of the paper would only have few tables or small tables. And then there's some tables like this one here, where you really just have a few data points, and it's not really worth plotting 3 dates at 4 sites in a figure, especially if it's not if you don't want to show a pattern, but just like have it as a explaining the rest of the results. So if people want to go back and check where did it snow, so how much, so because this is different snow depths. But this is more where you would hide the data. If it would be really important that it snows more at site S2 than at S0, you would still try to make a figure instead of a table. Because figures just are easier to understand at the first view and much nicer to show trends or patterns. But as you see here, this is from 2 very different journals, but the table design is very similar. You have the caption on top, just a few horizontal lines. Here they have a break in the lines, but no vertical lines, no little boxes around the numbers, just a very clean design, and that's what you find in most journals. So here I just show a PowerPoint table to highlight an additional point, which is, please, if you have numbers with a decimal point, arrange them in a way that the decimal point is always below each other. Because in this version, it's very hard to see what actually is the biggest number, because this is the longest, but it's the smallest, while this one doesn't include decimal points. Of course, it would also be a good idea to include the same number of digits in every number of the table, but even if you don't have it, please arrange it in a way that it's easily visible which is the largest number. I think I covered all this, so this is the last slide of my presentation. I hope you learned something about figures and tables. And we will have also in-person lectures, so you can ask all your questions and do your exercises, and we discuss the exercises. So thanks a lot for watching, and I hope you learned something.